Hi everybody, Morgan here. So we are moving on now to page 5 of the lecture outline dealing with stoichiometry. And we're going to be talking about excess and limiting reactants now. And I have often used the example of making a bicycle. For this. Now, when you put a bicycle together, you need one frame and you need two wheels. So we can actually turn this into a balanced chemical equation. One frame plus two wheels yields one bike. So, in theory, if we have two frames, we can say that we can make two bikes. But that is only if we have four wheels. If we have two frames and three wheels, we're only going to make one bike. We're going to run out of wheels. Okay, we won't have enough to make that second bike. And we will call wheels the limiting reactant, and the frames would be the excess reactant. Now, most of the time, it's not that simple. We can't do it in our head because we're having to deal with molar masses. But hopefully that'll give the idea about what's going on, okay? Now, we did this last year also, so a lot of this will be looking familiar to you, but I want you to practice it a lot because it is important. There are many different approaches to how to do this. I am going to take you through the approach that students have told me over the years is the easiest for them to understand. It's not the shortest, okay? But it's one that students say they get. If you're using another approach and it shows work and it gives you the correct answer, that's okay. I can figure out what you're doing. That's not a big deal. You just have to make sure that it shows the work, okay? So we have 100 grams of carbon tetrachloride. It's mixed with 30 grams of HF. What mass of CCl2F2 can be produced? How much of the excess is left over? So we're going to need a reaction C HF is going to give us CCl2F2 plus HCl. We balance it with a 2 there and a 2 there. So we start off with our 100.0 grams of CCl4 times. We can use our roadmap. It's a good graphic organizer so that we know what's going on. Okay, this will be our first reactant, 1 mole of CCl4. That's 153.81 according to my periodic table. You might have a slightly different rounding. I wouldn't panic on that. 1 mole CCl4. And we're converting towards the CCl2F2. Gives us 1 mole CCl2F2. And then that is 1 mole of CCl2F2. And on my periodic table, I got 120.91 grams CCl2F2. That will cancel that. This will cancel this. This cancels that. And I have 78.61 grams CCl2F2. Now that's my first reactant. Now for my second reactant. 30.00 grams of HF times equals 1 mole of HF. And on my periodic table, 20.01 grams of HF. Now here, it's 2 moles of HF downstairs because the balanced chemical equation for 1 mole of CCl2F2, 1 mole of CCl2F2 still has a molar mass of 120.91 grams of CCl2F2. Those cancel out. Those cancel out. Those cancel out. This time I got 90.63 grams CCl2 F2. Now, it's time for some discussion here. This reactant makes 78 grams. This reactant can make 90 grams, okay? I'm not going to get 90 grams because I'm going to run out of the carbon tetrachloride. That's going to make this the limiting reactant, and that's going to make this the excess reactant, okay? That means that I'm going to have some HF left over when I'm done. So, my favorite way of doing this, and kids say it works real well, is to say 90.63 grams minus 78.61 grams CCl2F2, CCl2F2, and get 12.02 grams CCl2F2, and that would correspond to how much I didn't make that I could have been able to make if I had enough carbon tetrachloride. 1 mole CCl2F2, 120.91 grams CCl2F2, 20.01 grams of HF. That cancels, that cancels, that cancels, and I'm getting about 3.978 grams of HF left over. Now, I've had some people say, take this difference, how come that's not how much is left over? Because that's not even HF. That's how much I couldn't make. Always label everything clearly, and that will answer most of your questions for you. Now, there are a lot of other ways of doing this, okay? I know that some people will take this number and calculate how much HF is needed and then just subtract it from that. That works well, okay? This is just what kids have told me they think is the most straightforward way of doing it, so that's the reason I'm doing it that way. There are other ways, okay? Now, let's try another one here. I'm reacting chromium nitrate, and it's a chromium 3. So it's CrNO3 sub 3 with H2S. That's going to give me Cr2S3 and HNO3. I'm going to end up with a 6 on that, a 3 on that, and a 2 on that. And the reason that I put this problem here was so that I would have something starting off with a solution in addition to something starting off with a solid. So I have my 1.54 grams of CrNO3 sub 3 times my 1 mole CrNO3 sub 3, 238.00 grams CrNO3 sub 3, 2 moles of that from the balanced chemical equation for 1 mole Cr2S3. Now, how did I pick what I was going to work towards? It didn't actually tell me which compound to work towards. This one did. Okay, this question doesn't. So I just picked one, okay? And typically I'm going to pick whatever has an easier molar mass to add up or something along those lines, okay? I'm just trying to make my life easier, and I got to tell you that 6 did not look appealing to me, and I happen to remember that the molar mass of this compound is pretty close to 200, so those were probably things that influenced me. Turns out to be on my periodic table 200.0 grams Cr2S3. If you broke out a periodic table and added it up with a few more sig figs, you'd probably get a better number. 0.647 grams Cr2S3. Those cancel. Those cancel. Those cancel. Okay? Now, for the second one, I've got 120 milliliters of 0.1 molar H2S. So I'm going to start off with 0.1200 liters, divide that by 1,000, times 0.100 moles over liters of H2S, so that the liters cancel, times 3 moles of H2S for 1 mole of Cr2S3, and my 1 mole of Cr2S3 is 200.0 grams Cr2S3, and then moles of H2S is gone, moles Cr2S3 is gone, okay, and I got 0.800 grams Cr2S3, dealing with some pretty small values here, but that's okay. We've got calculators to do this for us. All right, so obviously, because the smaller number, this is the limiting reactant, this is the excess reactant, so I'll have some H2S left over. I take the difference here, 0.800 grams minus 0.647, and these are Cr2S3, Cr2S3. That gives me 0.153 grams Cr2S3 times, and times 1 mole Cr2S3, 200.0 grams Cr2S3, 1 mole Cr2S3 for 3 moles of H2S, and 1 mole of H2S, 34.07. Okay, boom, 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 and I got 0.0782 grams H2S, meaning hardly any of it is left over whatsoever. Okay, so there you go. That's page 5 of the outline. I'd like you to go now and try and do all of the questions on page 6 on your own. Okay, this is Morgan signing off.